Welcome everyone. This is part of our Mastering Always On series with Cisco, and this week with WWT. We'll give another minute here as we see people piling in the room, and we are glad you came. So we'll get started here in just a minute. Awesome. All right. It is recording, and this is Cisco's Mastering Always On series. Today, we are going to be sharing some amazing things about resiliency, high availability, even upgrades with Cisco, and we're bringing in some brilliant partners that we are happy to share with you. But first, let's get a round of who we are, what we do. I'm Paul Hasted. I'm an engineer here at Cisco, been here for a little while, but not as long as the decade of experience that Mr. Brent, our senior solutions engineer, who will be presenting to us today on some amazing technologies. And not only is he a genius with technologies, but he's also the guy that saves the day, similar to what we have in our Superman series as well. And if that was not enough, Mr. Nathan over at WWT is a principal solutions architect, and he's not just any principal solutions architect. He holds two CCIEs with route, switch, and I believe security, which of course puts him into the genius status. And if that was not enough, if you're perusing his LinkedIn, his normal weekend reading list looks a little bit like this. So go ahead and check him out, add him on LinkedIn, and see what WWT and Mr. Nathan can help you with. With that, I wanted to share really quickly, as Nathan and Brent are going to be presenting with us, switching resiliency and how WWT can do such things for you and beyond. We also want to make sure that you stay all the way until the end, because we have a giveaway, and that giveaway, actually, we can test it right now, because we are going to give away an amazing piece of technology that you have to wait until the end of the presentation. But let's test it, because I wanted to ask that question: what is resiliency? And this is the part where you pay attention. You're looking at your screen, hopefully, but I want you to send me a direct message chat. This is how we're also going to be measuring the giveaway on who answers first and who answers correctly. So just for a test now, on your chat within your WebEx, go ahead and send me a direct message on what is resiliency. Is it mostly on, 50%? Is it always on? Is it something like your power company? Maybe is it more like a ISP? Chat directly to me. Let's see if I can start seeing some chats. Go ahead to the chat, direct message, Paul Hasted there on the panelist, or maybe let's see, chat with 10. Hey, there's one to all panelists. We got Tom in there, HA, 99.99999%. Yeah, Shiva thinks it's 100%. So sorry, Tom. Shiva thinks it's actually a little harder for you, right? Good. We got two answers. Keep them coming. What else? What else is resiliency? Anything? Fault tolerance. Love it. 85%. Wow. Okay. Marcotte. This is yeah, that's pretty low. You can take some hits, but stay available, stay alive. Okay, I like it. See, because there's a lot of variance between maybe what you believe is resiliency. Mike thinks 99%. And maybe what your business thinks is resiliency, and or maybe what your customers think is resiliency. For me, resiliency might look a little bit something like this, because we all have one of these, or maybe you grew up with one of these, and you probably you didn't have a different one. You don't have like a way to swap out a compressor on the fly, but you knew you needed some resiliency when what happens? Yeah, stuff starts leaking out. And then all of a sudden, you're done. You're down your hose. You normally didn't actually realize you needed resiliency until it's too late and you've lost food. So, what can we do with all of the technology that Cisco has to offer and with our partner from WWT? What can we do to make sure that you don't lose or getting yourself in a tough spot? And with that, I want to introduce to you Mr. Superman himself, Mr. Brent, who is going to share with us some of the innovations that we have within switching resiliency.
Yeah, thanks, Paul. Thanks for the introduction there. Hey, folks, appreciate the time here today. So what I wanted to quickly start off with was just making sure that everybody's baseline on the current Catalyst 9K portfolio. This will be the focus of the discussion from a resiliency standpoint. But a couple of things I did want to call out, we have, closed the gap in terms of, next generation platforms from our, generation type 1 platforms that you kind of see along the bottom here. But what's important to understand is, like when we look at our access portfolio, we did introduce the 9300 and the 9400X series. And again, some customers feel like, hey, that's just the next switching platform from Cisco. But the reality here is these were actually purpose built for specific use cases. So the idea behind these platforms are, understanding that we're going to need higher UPoE plus port density. We're going to need higher MGig density. And that's really what a lot of the focus was here, helping customers enable new innovation and use cases like smart buildings, Wi-Fi 7 AP connectivity. So all of these things are driving more MGig, more PoE requirements, which leads into some of the things that you can kind of see here on the slide. And as we transition over to kind of the core platforms on the right-hand side, you'll also see that we've introduced the X series. And some of these platforms are actually running a newer ASIC from Cisco, specifically Silicon One. And if you're not familiar with that ASIC, effectively what we've done there is we've taken kind of the best ASIC from what you would expect from a switching platform. So think of high speed, high performance ASIC, and combine that with the scalability that we get with a routing platform. So we've taken the best of, deep buffers, large table sizes, high performance switching, and we've combined them into a single ASIC. So that's kind of what Silicon One's all about. Now, before we dive into resiliency, as Paul was asking the question, I've kind of made a very broad assumption here. My assumption is that everybody understands the importance of resiliency, right? At the end of the day, there is no connectivity without the network. So the focus here is going to be how do we, provide the most network availability possible, whether that's, looking at types of outages, right? So there are different types of outages, unplanned outages, things that are maybe outside of our control, a supervisor module crashed or a switch died, or maybe it's even something like a config mistake, right? And then we get into things like planned outages or planned maintenance, right? Hey, I need to take a piece of hardware out of commission to upgrade or maybe do device refresh, but I still want to maintain network availability. And at the end of the day, the whole goal here is to minimize kind of the impact on clients, network, and applications. Now, I put this slide in here, and the reason for this slide is you're going to hear this terminology used quite a bit in the discussion here. So I wanted to make sure that we baseline everybody on the differences between the control plane and the data plane, because this will come up in all of the conversation that we're going to have here today. So when you think about the control plane is really responsible for communicating with neighbors, establishing routing adjacencies, learning all of the available paths in the network. And it's really responsible for maintaining kind of the state of the platform, right? So think of the running config, the routing tables. All of those things are handled by the control plane. And this is typically done in software. So think of a CPU that's responsible for the control plane. Now, when we get into the data plane is actually responsible for the forwarding engine, right? So think of the actual FIB or the forwarding information base or a Cisco Express forwarding table. That is the data plane. And typically that is done on an ASIC. So think of, line rate forwarding on an ASIC, that is the data plane. So a simple analogy is, maybe the control plane is the Google Maps, right? It knows everywhere, every way to get somewhere anywhere you're at, right? But it's not actually responsible for helping you get there, right? That is more the navigation platform or the car that's going to take you to the destination. That is the actual forwarding plane, okay? So one's responsible for understanding where everything is at and maintaining state of that. The other is determining what is the best transport and path to get there. That is the data plane. All right. So you'll hear these terms come up quite a bit. So let's focus first on like what are the pillars of resiliency? And there's really three core pillars when we look at resiliency. Number one being platform resiliency. This should be pretty fundamental, right? Think of things like I'm going to have redundant supervisors. I'm going to deploy a switch stack, right? I'm going to put redundant power supplies and fan modules. Then we move on to things like design resiliency. How do I build designs that eliminate or mitigate single points of failure within my environment? And the last one here is all about operational resiliency. Okay, these are kind of, think of day two changes in your environment that could have an impact and how we can help. So looking at these three pillars, we'll jump right in. So when we look at platform resiliency, it's quite simple. From a fixed platform perspective, we offer technology like StackWise, which we'll talk about, stack power, redundant fans, power supplies, uplink modules. These are all from the platform perspective. When we look at our modular-based platforms, whether that's access or core distribution, we're talking about things like redundant supervisor modules, again, redundant power supplies, fans, etc. And then even if we're looking at maybe a collapse core, traditional core platform, even if it's fixed form factor, we can still provide some of that platform resiliency with things like StackWise Virtual, MLAG, and things that we're going to talk through here today. All right, and the net of this is what you're going to see is all of this can have sub-second traffic impact during any type of failure across all of the Cat9K platforms in the portfolio. So let's look at resiliency at the access. So in the access layer, we really have a couple of options, right? We can deploy a Catalyst 9300 switch stack. And really what this results in is we get to a unified management plane. We get to a single unified control plane, meaning there is one active control plane and one hot standby. And this is what we call a distributed forwarding architecture. What does that actually mean? Well, if you think about each one of these switches has its own ASIC. It has its own forwarding capabilities, hence distributed forwarding, okay? Now, when we look on the other side at a modular-based platform, we still have the same concept. It's a unified management platform. It's a unified control plane, right? Still have the active standby just like we do with StackWise. The difference here is the centralized forwarding architecture. So what does that mean? What we've done on all of the Cat9K platforms that are modular-based is we've built a lossless backplane, and all of the forwarding happens on the actual supervisor modules. So all of the forwarding engine is really the ASIC that resides on the supervisor modules of this platform. So gone are the days, when we had 6500s and some line cards had, individual route processors or distributed forwarding cards on them. That was kind of distributed model, right? So now we've gone back to this centralized forwarding architecture. So those are kind of some of the key differences here. And then as a best practice, obviously we want to have things redundant in terms of connectivity. Now let's look at failures in these scenarios. So we leverage protocols like stateful switchover, and stateful switchover is really responsible for synchronizing all of the information that you can see up in the table, right? Again, the control plane synchronization. And this is all the L2, L3 information, the running config, interface states, the routing table, all of these things are being synchronized in real time, including this forwarding information base. So when we have a stateful switchover, we're able to still leverage the existing forwarding table to prevent any type of real impact when we have active go to a standby module. And in this case, we're able to achieve less than 200 milliseconds of impact when we're failing from whether it's a StackWise virtual environment or we're running like dual supervisors in a chassis-based platform. All right, now let's talk a little bit about the distribution in core. This is where things I think get a little bit more interesting. And first, I think we start with what does a traditional network look like for most customers? I won't say this is all, but the majority of customers are still leveraging kind of this layer 2 domain. And we all know the nuances that come with layer 2 spanning tree, layer 2 hardening, first hop redundancy protocols, and things that we need to take into consideration. There's, ways to get load sharing. You can do odd and even VLAN load sharing and match spanning tree and HSRP priorities. Again, a lot of manual tweaking and tuning of timers and protocols in order to kind of get these to load share. And again, what this represents is a distributed forwarding and distributed control plane, right? Each one of these is representing a separate control plane. So with Stackwise Virtual, what we're doing is we're taking that single or the distributed control plane, we're combining it into a single control plane. Why has this piqued interest from a lot of customers? Well, when we combine this into a single control plane, we get a unified management plane. So I can configure this as one box now. It looks logically like one switch. You have that centralized control plane architecture. We eliminate all the spanning tree, first hop redundancy protocols, and all the things that I just mentioned. We get to active-active forwarding using technology like multi-chassis ether channel. And we can still achieve sub-second failover in this type of architecture. Okay? So let's look at that. What does Stackwise Virtual look like? Again, we have an active, we have a standby, single control plane. And we're using SSO to synchronize everything that I mentioned previously. All of the routing, the forwarding, L2, L3 information. And in this case, because again, we're using stateful switchover and we're maintaining this forwarding information base, again, regardless of the scenario, Stackwise Virtual, Stackwise, or redundant supervisor modules, any impact to the active failing to the standby is going to result in less than 200 milliseconds of disruption. Okay, now you may be thinking, okay, well, stateful switchover is typically used with another protocol, and this protocol is really responsible for the layer 3 forwarding. So this protocol is nonstop forwarding. You can also maybe interchange this with graceful restart. Okay, they're pretty interchangeable, but the idea here is, yes, we're continuing to leverage stateful switchover to maintain everything in the table up top, but we're also going to leverage nonstop forwarding to make sure that when we lose a control plane, that we're preserving the packet forwarding from the fib that we previously had, but we're basically, buying a grace period. This is where the graceful restart came from. Basically, we're asking for a grace period of the routing protocols not to basically try to renegotiate adjacencies and topology changes and be disruptive. We're basically saying, hey, let's freeze those hold down timers. Let's wait for this standby control plane to become updated, and then let's update as needed versus let's reconverge everything upon failure. So NSF is really buying us a little bit of time, which is where the graceful restart comes from. And this allows us to kind of, again, maintain that seamless kind of, even if I'm failing between active and standby, I still can achieve less than a 200 millisecond impact. Now, what if I'm a customer that's running maybe a traditional layer 3 routed environment up top? All right. Well, same concept, right? This is nothing more than a chassis or a modular-based platform with dual supervisors. So we're going to have the same thing that we saw at the access layer, whether it's 94 or doesn't really matter the platform, we're still able to achieve, less than 200 milliseconds when we're going from active to standby. Okay, so this would be like a true L3 core. We're using equal cost multipath. This is non-Stackwise Virtual, just your traditional layer 3 kind of core device. Okay, so we can still get that through dual supervisors. Now, what if I've decided that, hey, I'm going to choose to run Stackwise Virtual even in my core platform? This comes up quite a bit. Like, how does this actually work? So what you're looking at, again, is two modular chassis, both with dual supervisors, and they're in a Stackwise Virtual environment, meaning, again, single control plane with dual forwarding planes. So because we've joined these as a single control plane, effectively what ends up happening is when there's a failure, this supervisor module is actually going to fail to switch to's supervisor module. And what you're looking at is this RPR nomenclature here is for route processor redundancy. Basically what ends up happening is this active sup fails, this supervisor takes over, and this supervisor here goes into RPR, which it will reload, and it will now resynchronize with this new active supervisor. So if you think about, if you had 4 failures, it would basically be a Z. This device fails, I jump here. This device fails, I jump down to the second sup and switch 1. If this sup were to fail, I would fail back over to this sup. So this is called Quad Supervisor. This is supported in the 9600 platform, and this is kind of how that works. So not traditionally where we would fail from soup here to the secondary soup within the chassis, we're actually failing between chassis. Again, regardless of how we're doing that failover, it's still about less than 500 milliseconds for this convergence to happen. And what you're seeing here is 6 to 8 minutes. This is in chassis standby. This is that reload, right? So as that route processor is reloading, and then it's going to join the active and synchronize, that is going to take about 6 to 8 minutes. Okay, moving on. This is something that is new. Now, why are customers interested in what we're calling EVPN multi-homing? Well, if you can see from this diagram, it's a little bit different. Number one, we're looking at 2 individual active control planes. So again, Stackwise Virtual is a single control plane between these 2 devices. With EVPN multi-homing, what we're doing is we're saying, nope, we're going to have both active control planes, and we're actually going to have both active data planes as well. And you'll notice that there's no layer 2 connectivity, there's no SVL or dead peer detection links. Those things are not going to be required with this technology. But what this allows is it allows us to maintain independent control planes. We still get all of the benefits of things like Stackwise Virtual. So you get active forwarding from your access layer. So we're no longer bound by spanning tree limitations and those things. And the way that we're solving that is we're using ESI or Ethernet segment identifiers to ensure that this topology stays loop free. Okay. So this technology is interesting in use cases where, hey, maybe I'm in a multi-vendor environment. This will be a great solution that can interoperate with other vendors. It doesn't necessarily just have to be Cisco. Maybe I'm operating in a highly critical environment. I deal with healthcare a lot, and Stackwise Virtual is great, but it does come with some caveats, and we're going to get into that in the serviceability piece. But there are use cases where EVPN multi-homing, because I have independent control planes, when I go through a software update, I have some new capabilities that I didn't have with Stackwise Virtual. We'll talk about that when we get to the upgrade section. All right, so this is something that's coming. This will allow us to get to 0 downtime. Think of this as almost like your traditional L2, L3 environment, and you're tweaking and tuning protocols, but you're not having to do any of that. This is all working out of the box using the Ethernet segment identifier to help you keep all of this topology loop free, do active forwarding, and still maintain active control planes. All right. So now let's focus on that last pillar. So the last pillar was really focused around the operational resiliency. So really, how do I perform maintenance in my environment, and how can Cisco help? So what are my options if I'm running a traditional network design that looks like this? Again, maybe I'm running spanning tree, I have first hop redundancy protocols. Again, there's nothing wrong with this design. It's a very well-known design. It's been deployed for a very long time, so it's very well understood. But in an environment like this, you would need to either build scripts or you would need to manually come in here and tweak things, right? I need to adjust HSRP and spanning tree priorities and tweak the routing protocol to my core up here so I can start to, have routes come through the secondary device, because the idea is I want to take a device out for maintenance, a software upgrade, etc. So even in this type of design, we offer something called graceful insertion and removal. And really what this technology is focused on is, with a very simple command, start maintenance, we will basically tweak and tune the protocols, both layer 2 and layer 3, to steer traffic through the secondary device. Okay? So it's basically eliminating all the manual effort that you would need to understand from an L2, L3 perspective. And it's very simple. Right? You basically issue this start maintenance command, and there is a lot of capabilities here. There are specific templates that you can use with GIR, but at the end of the day, the outcome is we are going to tweak the L2 and L3 protocols to basically perform traffic steering through the box that is going to be going offline for maintenance. Okay. And so now if we look at, okay, that was traditional, maybe we can use GIR, but what if I've decided to deploy a Stackwise Virtual design? Well, now I have this single control plane. Well, the good news is regardless of what you're doing with Stackwise Virtual, if you have Stackwise Virtual on a fixed form factor like a 9500, we can leverage in-service software upgrades. Okay. In-service software upgrades are leveraging the protocols that I mentioned, NSF and SSO on the back end. That's how we're getting to this seamless upgrade. And in each one of these cases, regardless if I'm doing Stackwise Virtual, regardless if I have dual supervisors in a modular-based platform and I want to do ISSU here, or maybe I have kind of this active standby model of chassis, I can still do an ISSU upgrade. And the good news is in all of these cases, it's less than a second, right? Again, this was the use case that I talked about with RPR and the quad soup use case on 9600. Yes, we do support ISSU. It just takes a little bit longer. The 500 milliseconds is what we're calling out here. Now, the only caveat that we run into with Stackwise Virtual and in-service software upgrades is that we only support in-service software upgrades between extended maintenance releases or within an extended maintenance release. So you can't go between 17.3.1 and 17.4. That's not a supported upgrade path. So you can go from 17.3.1 to 17.3.2, 3.3, 3.4. All of those are fully supported ISSU hitless upgrades. If we're going from an EM to an EM release, that is a fully supported upgrade as well. So again, this offers about a 3-year software life cycle. This is where we recommend customers to be, is on these extended maintenance releases. This is where we do all of the security vulnerability and defect patching. So it's recommended to stay on these. But again, I go back to the critical healthcare environment, right? If there's absolutely zero tolerance for downtime or zero tolerance for maintenance windows, Stackwise Virtual with ISSU may not be the right solution, okay? So what are my options if I have Stackwise? Again, my access layer, we have some limited options here. Again, at the end of the day, I'll build these out pretty quickly. Even with a single standalone switch, we can leverage what we call extended fast start upgrade or software update. This is less than 30 seconds of impact, whether it's a standalone switch or if it's a stack of switches. Both are going to have the same convergence time. So again, we're swapping the active with the standby. We're using the same protocols that I talked through earlier. And again, less than 30 seconds of impact. However, with later versions of software, starting with 17.15, we're able to actually get this under 5 seconds. So there's actually been some numbers that we've done some testing with. I think it's pretty impressive. We're going to continue to work in this space. Again, we want everything under a sub-second, everything that we're doing from a software resiliency perspective. So you'll see these numbers start to improve. But this is geared towards, I have an access layer. It's a stack of switches. I typically don't have things that are dual connected, right? So this is what we can provide in a stacked type environment. Last couple slides here, folks. The last one here is around software maintenance upgrades, what we call SMOOs or software maintenance updates. Why are these important? Well, if I'm a customer that spent time certifying a certain version of iOS XE, maybe I'm doing bug scrubs, maybe I'm paying for a service for somebody to do bug scrubs, or maybe I've just invested a lot of time myself digging through, the release notes and really understanding, is this a stable version for my environment? You go through all that effort and all of a sudden there's some security vulnerability that comes out. It's easy for us to say, hey, just jump to the next major release. Well, that means I've got to redo all of my regression testing and recertify that version of software, et cetera. So the idea behind software patching is iOS XE runs subsystems within the operating system. And those subsystems give us the ability to patch an individual subsystem without impacting the overall operating system. Okay, now some of these can be hot patch, meaning I don't need a reload. Some are cold that do require a reload. Okay, so this is critical, I think, in healthcare environments, anywhere where we're spending a lot of time doing software analysis and bug scrubs and things like that. This tends to be a well-adopted feature. All right, summarizing, whether we're in the access layer with a stack of switches, whether we're in 9400s with dual supervisors in our access layer, whether we're doing ISSU in our distribution, we're doing MLAG, we're doing ISSU with dual soups in a traditional manner, or ISSU here with our true L3 core. All of this is sub-second minus kind of the iOS, the XFSU, the extended fast start upgrade. Everything else is sub-second. Again, we covered all of this, so high availability at every layer, leveraging a lot of the technology I just talked through. And last slide here. This is where I spend a lot of time with customers. It's helping customers understand based on, a lot of the conversation is around the distribution. The access layer, we're always limited. We don't have things that are dual attached typically. So, there are times where Stackwise Virtual is a great fit, pending, the ISSU caveats I called out. MLAG, which is coming, is going to solve some of the challenges that we have with Stackwise Virtual. Customers are deploying layer 3 routed access, but then we run into challenges around, we don't have IP mobility. VLANs are now locally significant, right? Hence why on the far right, you're starting to see these fabric-based technologies become more and more prevalent, right? We eliminate all the layer 2, we solve the overlay challenges, the IP mobility challenges, all of those things we solve. So with that, I'm going to turn it over here to Nathan to kind of talk about how can WWT help in a lot of these scenarios? And then what are you actually seeing from some of your customers, Nathan? And maybe give us a scenario that you've been through. Bring this to life for us.
Awesome. Appreciate that. I'm going to go ahead and bring mine up. All right. Thanks, Brent. That was awesome. Tons of great content there. And thanks again to everybody who joined us today. We understand that your time is valuable, so we appreciate you spending it with us for a little bit. Again, Nathan Nielsen, I'm a solutions architect on our global solutions and architecture team. And I did want to take a few minutes to introduce the company, WWT, for those who may not have heard of us or just maybe unaware of some of the unique offerings that we can provide you. So we are a global technology solutions provider founded in 1990, so 35 years ago now. And we are founded by Dave Stewart and Jim Kavanaugh, who both still own and run the company today. They started with just the two of them selling laptops out of the back of a rental truck. And now they've got more than 10,000 employees across the world and one of the largest privately held companies in the United States. But we also became a Cisco partner a little over 25 years ago. And we like to consider ourselves their top partner. And many of our financials and offerings kind of back up those claims a little bit. For example, this is a list of our current partner specializations and certifications that we hold. Certainly too many for me to go through. I'm not going to name all these, but as you can see for yourself, there aren't too many things that can come our way that we're not capable of handling. But on top of the specializations and certifications, Cisco holds an annual partner summit each year where recognition is given to kind of the top partners, top contributors, and so forth. And these are the awards that we were able to walk away with this year. So again, a good bit of areas that we're covering and even exceeding and performing. And although we weren't able to walk away with every award at this last summit, we do have a lot of things that I feel like differentiate us from the crowd. One of those being our organic growth, and the fact that we're a large company that's privately held, and I'll go into why that matters here in a little bit. We've got a global supply chain that is more than just a supply chain. We'll also touch on that quickly. We have our digital platform, WWT.com, and I'd like to invite everybody to head over there at some point. We'll touch on that again at the end, but it is more than just a website. There's tons of content on there that us as engineers and architects can benefit from, whether you're purchasing services and solutions from us or not. There's a lot of just great content on there. We have app dev capabilities. So if any of you have ever used the Little Caesars app or Panera Bread to order your food, surprised WWT actually developed those apps. And that was a surprise to me when I came to the company as well. I didn't realize that was one of the many areas we cover. So again, a few different ones. I'm not going to go into every bullet, but we are diversity owned. For the last 13 years in a row, we were recognized as Fortune 100 best places to work. And then last but not least is our lab and advanced technology center, which we refer to as the ATC. In this one, it gets its own slide. I am going to do my best not to spend too much time on this, but it is a little difficult because this is actually a really big deal. We are, again, the ATC, our Advanced Technology Center. It is one of the benefits of being privately held and financially sound, and the fact it's that we have the freedom to innovate and to make investments. And Jim and Dave have gone all out on this one. When I started with the company 6 years ago, we had around 500 million in infrastructure investments, and that's nearly doubled within 6 years. And what this is it's a state-of-the-art lab that consists of just about every hardware and software combination you can possibly think of, and a team of highly skilled technologists to support that. So, in addition to more than 20,000 virtual instances in the ATC cloud, our physical footprint consists of more than 500 racks worth of equipment across 5 different data centers. And somebody might be thinking out there right now, like, what on earth would you need a $1 billion lab for? And really, this is for us to provide that level of value to our customers that is just not seen out there anywhere else. It gives us the ability to accelerate and what we call de-risk architectural solutions for our customers, like well before deployment ever even happens. And that's through product testing, comparisons. We do design validations. We can do, what's referred to as a bake-off, where there's a few solutions that a customer may be considering, and they're just not positive which one's going to work the best for them. We do proofs of concepts. We have all sorts of research happening, and the research is again our specialists who are keeping a pulse on what's happening out there in the industry and the direction that technology is going in, and providing information for you to be able to just look and say, oh, well, this is how this is evolving, and this is what we can compare it to. We have tons of hands-on labs that would only require if you come to WWT.com and register with your business email. You'll have access to on-demand labs that are completely free, and learning paths. The learning paths are where you say you want to learn a little bit more about BGP or something. You can sign up for this learning path, and it's a combination of videos and hands-on labs that have been put together. And at the end, you get like an achievement badge where you can use that. It's just a ton of great stuff. We've got proof of concepts are obviously next level with a $1 billion infrastructure there. And one of the main things that this provides is it's architecture validations. We have the ability to simulate traffic and do stress testing. It's anything you can possibly think of. Our cyber range, we do capture the flag activities, where we have like a red team and blue team sort of thing, where we're competing with each other. So really cool stuff. Again, I would love to keep going on this slide about how amazing the ATC is, but we've got a few other things that we need to cover too. So another large area where we shine, pun intended, it's the 4 million square feet of integration centers that we have across 3 different continents. And the reason that we call them integration centers instead of distribution centers or supply chain is because we can act as your single point of contact to procure hardware and software, design, build, test, and deploy fully integrated systems. And when I say fully integrated, I mean we have, if you see in the top left there, 325 concurrent rack building stations. This just, I was amazed when I did the tour of this place when I first started, and they will fully populate your racks with servers, your networking equipment, cable everything up, and it's having the specifications that we receive from our customers as far as what software version they need to run, the exact configurations that need to be on devices, and we can build out entire racks worth of stuff and drop ship them to your location, where the only thing that's required is power to the rack and an uplink, and you're fully up and running with the configuration that you gave us. So it's pretty amazing. Next, we have our branch services, where not only can we mass produce and mass distribute hardware fully populated, configured, and so on and so forth, but we also have the ability to roll these services out. If you need a hand in deployment, we can handle any size network out there. We can ramp up and scale out as far as the customer can probably handle. And looking at these numbers on the screen, this is not like our cumulative numbers over the 35 years that we've been in existence. Like these are annual averages. So that 250,000 access points, the 3 million endpoints, like these were last year's numbers. And so I've mentioned a few of these, but another key another key thing that sets us apart is just our vast services portfolio. We do everything from consulting to strategic resourcing, where if for staff augmentation, if you need a resource for this year-long engagement and you don't have that person on hand, we can provide them for you. We fully, we make sure that they've gone through their screening, their certifications, all that kind of stuff. We simplify complexities of transformation and enable our customers to avoid like fragmented workloads by having to go one place for this thing, another place for this thing, and forward. There we go. Sorry, slide wasn't forwarding. And in the end, what these capabilities provide is a unique scenario where we can deliver from the very first conversation and idea that somebody has to the whiteboard, to briefings, to demos, to workshops and proof of concepts, all the way to the end where a decision, an educated decision is made on a technology, on an architecture, things have been vetted out. We can roll them out, and all the way up until the final documentation of a deployment project, we can start to finish. It can be your one-stop shop. And the way that we align with our partner Cisco, we have business units that we have developed, and as far as business needs and our customers' use cases, these are just some of the things that may come up. I need to securely connect my workers. I need to automate everything that I can. I need to engage my customers. And within our organization, we have a different business unit that handles every one of these possible areas. My area personally is on the connected workforce, and we've got thousands of individuals across the rest of these teams, and we closely align with each of these offerings from Cisco, where we have a solution for you, Cisco has a solution for you, and we have the ability to deliver on that. So jumping back over to the conversation of resiliency, Brent did an amazing job going through these scenarios, things when you may want to consider one over the other. So this is a little bit more of a review, but it does have a story that we're telling with it. So I'm just going to kind of take you through the history a little bit here. 2 decades ago, this was kind of a pretty standard topology that you would see here. And again, it's fully layer 2. We're not doing stack-wise virtual in the core. We have first hop redundancy protocols and all of those tuning and tweaking that Brent mentioned, where you may have priorities for these. You could sort of load share, but then you've got like your tracking statements in case this one interface on this firewall happens to go down, and you either do or do not want gateways to roll over. So there's pros and cons there. Consolidating the control plane there gives us the ability for that multi-chassis ether channel, where one of the main downsides to the full layer 2 environment is, I think the worst thing is just the size of the broadcast. I mean, is the problems that can come along with that. But it's also the fact that half of our links are blocking. We have redundant links all over the place, but we have half of them blocking and they're not being utilized. So move into that consolidated control plane with Stackwise Virtual. It eliminates the need for our first hop redundancy protocols. And then it also can allow us to bond our interfaces across chassis so that we're opening up that forwarding path. Something that may be even better and a lot more common that we're seeing today, again, is moving that Stackwise Virtual down to your distribution layer. And for customers that have a distribution block that's not big enough where you need multiple sets of distribution, where you have the port density for a single distribution block to handle all of your access switches. We've seen a lot of customers moving their gateways down to the distribution layer. Again, in a Stackwise Virtual scenario, you'll have a single control plane. You'll have the ability to aggregate your layer 2 links. So we don't see all these X's on here where things are blocking. What we still have, though, is the size of our layer 2 broadcast domains, and we still have the potential for a misconfiguration on a port channel. And I've seen multiple times where a misconfigured port channel brought down entire sites. So another thing that we have seen gain interest is where customers would bring layer 3 all the way down to the access layer. And we know how resilient equal cost multipathing is. It was mentioned earlier. This is one thing that most people that I hear in the industry agree on: the fact that there is all paths are forwarding. There is no reconvergence if a link goes down or if a device goes down, because all forwarding tables have all available routes, and they're actually passing packets on each one of them. So if a link becomes unavailable or a switch in the path becomes unavailable, nothing changes. It just keeps forwarding on the rest of the links. So as far as a self-healing and resilient deployment, full layer 3 with equal cost multipathing is hard to beat. Now, it does come with its disadvantages, though, and some considerations that you would have there is that, number one, it's a little bit of a heavy lift to get to this point. If you're running one of those traditional full layer 2 across the board scenarios, it's a bit of a lift to get here. Another thing is the overhead. I've seen customers where it's VLAN 10, 20, 30, and 40 on every single switch for data, for voice, and it's fine. That's consistent across all of them. But the catch is with routed access, those have to be unique subnets. So whatever switch your endpoints happen to be connected to, they're going to be in a different subnet with a different gateway. That's how many subnets you need to plan out. You have all of your DHCP scopes for each one of them. So there is more overhead and more planning and more configuration that may need to go into such a scenario. So taking this one step further, we heard of the campus fabric deployment. Software-defined access is something. So software-defined access is a version of campus fabric. The software-defined piece is that it has a controller or an orchestrator. But just from a campus fabric perspective, this is where you see the underlay and the overlay technology come into play, and it's kind of the best of both worlds, where the underlay is your layer 3 ECMP. From a forwarding perspective, it's still all routed, it's still all packets. The change here is that now you have an encapsulation through VXLAN, where your data plane is using, you've heard terms of layer 2 over layer 3 or UDP and MAC and UDP, but traffic is essentially tunneled from access port to access port. You're encapsulating an access port, you're decapsulating it wherever the destination of that flow is. So what that provides for is tunneled traffic through this campus fabric. An additional benefit to that is the Anycast gateways that are provided in this case. It's one segment that will have the same gateway across every single access switch. So instead of having 5 subnets on one, another 5 on the next, another 5 on the next, it's the same subnet across all of them, except the primary benefit there is that it's not actually a stretched layer 2 broadcast, even though it's a stretched subnet, because your flow of traffic will encapsulate ingress on the port, wrapped in layer 3, routed to wherever the destination is, and then decapsulated and passed out on what appears to be the same broadcast domain, even though it's technically not. It's layer 2 adjacent. Broadcast domains actually end at the port itself, where it's encapsulated in layer 3. So, not to get too deep into this, we'd love to have further conversations with you about this. Please reach out if you want to hear more about it. I love this topic. But another one of the benefits you get on this is pretty much out of the box macro level segmentation. Not only are we seeing a lot of networks split up from a VLAN perspective, but we have VRFs where we want to completely keep this traffic isolated. We have policy that we may want to put in place to where certain segments, certain endpoints within a segment don't talk to other ones. And so the upside to this is lots of feature rich. It's the carrying of these tags through the tunnel. It's the full resiliency. The downside is more complexity. And I wouldn't say downside, I'd say it's a consideration. There's absolutely a lot more complexity here, but don't forget about your orchestration platform. Catalyst Center is there to implement these sort of solutions with us, with standardized and consistent configurations across the board, where we're using something a little bit more intelligent than us to come up with the configurations at scale, where we're not having to manually jump into each device, configure these tunnel configurations and so forth. So I went through that whole history there to try to just kind of paint the picture for this real world scenario that I wanted to share. We have a customer that we were working with that are, roughly 7 billion in revenue. So not a small organization by any means, more than 30,000 employees. And they, typical story where they absolutely have an aging infrastructure because there's so much of it, but there's also been a few acquisitions along the way where it's caused a few levels of complexity through just having non-standard configurations and different things built out in different ways, a lot of different hands within the cookie pot. So one of their acquisitions in particular, it wasn't their largest one. So they had a layer two collapse core, fully layer two across the board. And they had some, I've got tuning in quotes because again, like what Brent mentioned earlier about the tuning and tweaking, this is a term that we used to call back in the days, kind of a poor man's load balance, where you would use parameters and you would use priorities and you would do tuning to try to load share traffic. It wasn't really load balancing in a sense because it was splitting paths. And in this case, with it being full layer two, no consolidation of control plane, you have not only are some of your links passing, what they had configured in this situation was half the VLANs were root bridge on one switch, the other half were root bridge on the other switch. So you had some paths that were blocking for these VLANs and some that were forwarding for these VLANs. So if you look at this on the screen, you can just see like the type of headache that from a management perspective that this could possibly be. To make things worse, they would, so they would have instances where layer two events would cause outages, and they would bring, this being a full layer two deployment, it would bring the entire hospital down for 20 to 30 minutes. So if you can imagine a hospital completely down for 20 to 30 minutes, that's an extremely big deal. In fact, it was so bad, their last outage, what they ended up doing was going through and physically disconnecting all of their cables from the second core because they lost remote access due to the layer two issues. They didn't really have storm control configured in an effective manner. And it would take somebody getting there on site to console into things to bring stuff back up and shut down this SVI and no shut this one according to however that stuff was split. And so they figured it was the lesser of the two evils was just to unplug all the cables from the secondary core just to get them stabilized, which obviously is another dangerous situation to be in. So fortunate for us and for them, we were already under contract to do a refresh and a campus fabric deployment, and it was a completely different use case. Though in this case, it was a segmentation initiative that was driving the implementation of this next generation architecture. And the one of the benefits, though, is that they had noticed the first few sites that we'd been to through, it was a noticeable difference in stability. So great, we've got a vehicle for automating our segmentation strategy, but now we've got these really resilient environments. And so the business came to us and they're like, hey, any chance that this new thing that we're deploying at these other places could possibly fix this one thing that we're having? And it's very rare in IT or in networking especially that you can say you're 100% sure about something. In this case, we were literally like 99.9% sure, like, yes, this implementation is going to fix the issues that we're having there. So since we had a standardized design, we had a templatized implementation strategy, we were able to make some swift adjustments in the project schedule. And we had this hospital entirely migrated over and fully stabilized as a result within a matter of 60 days from finding out about the problems that they were having there. And usually we're working kind of with our local staff. I'm sorry, like the technical staff. This was the first time where the actual hospital staff was thanking us in the hallways for whatever we did to fix their hospital. They were just grateful for the stability that they were able to recognize there. And we have another POC that's in place right now. It's a really large retail environment where they're having similar layer two instabilities where they're like, listen, we are interested in a campus fabric purely for the resiliency that we would get out from a routed access, but also an Anycast gateway routed access. So before I hand this over to Paul, I just want to go through a quick thing. I do want you to come and visit us at WWT.com. We have our platform here, tons of stuff, what we do, all of our capabilities are listed there. Learn from us. The tab is going to show you kind of our learning paths, our hands-on labs, things that you can get to. And if you're willing to, if you're interested in reaching out, there is a contact us tab, or you can just go to wwt.com/contact us. And we would love to talk with you and see how we can partner with Cisco in a solution and keep your environments highly available and fully resilient. And with like that, I'd just like to say thank you to everybody again for your time. And I'm going to turn it back over to Paul.
Awesome. Thank you, Nathan. That is amazing. And we love the partnership. Again, just to be reminding of all of y'all, the superhero powers of Brent out there showing you the amazing architectures and technological efficiencies that Cisco can provide you, plus the genius of Nathan. Of course, the Einstein, imagine Superman plus Einstein, and Einstein having the tattoo of WWT. Like that's literally the ultimate resiliency package right there. So with that, please reach out to your account teams, reach out to WWT, how we can make sure that your infrastructure is ultimate resiliency and always on. But what about the giveaway? We promised something for y'all, and almost still 100 of you hanging on with us. That's going to be a beautiful MS-130 for those of you who can answer the quick fingers. So we're going to do a quick test, the giveaway question test right now. This is the test. Can you type quickly? Not only type quickly, but direct message. Don't send it to everyone. Don't send it to the panelists. Send it directly to me. And here is your first giveaway question test. What is the name of the cloud networking group Cisco purchased in 2012 for $1.2 billion? I'll give you a clue. That's the OG logo. And now I'm looking for my direct message. Bang, bang, bang. Yeah, we got a couple of you. And now I'm going to be looking at this. Yes, awesome. Blair's got it. Jason's on it. All y'all keep going, keep going, keep going. So this was the test. This was only a test of the emergency broadcast system to keep sure your infrastructure. Yes, it is Meraki. Now, there's a real deal for the MS-130. Here comes your first question. Number one, it is multiple choice. It is multiple choice. You don't have to type out the answers, just type out the multiple choice answers that you believe are best. With all the sub-second solutions presented by Superman Brent himself, when would you choose MLAG instead of Stackwise Virtual? Choose all that apply. A, all devices are the same vendor. A mixture of vendors to ensure interoperability. B, and C, when you need active forwarding. Or D, all of the above. Shoot me your answers. We are starting to get some things rolling in. Choose all that apply. There might be a little trick in this one right here, and that might be my fault, but we'll see. If anyone's paying attention, we got some answers flowing in. Keep them coming. Keep them coming. We'll give you about 10 more seconds. We got our first right answer brought into you. Okay, yeah, it took a second. You had to think about it. You had to think about it. I love it. All right, keep going. I'll give a couple more seconds. And yes, thank you, Nathan. Reminder, send it directly to me instead of everyone. I'm just watching and monitoring. What is that answer? Yeah, B and C. Of course, that A, when you're all the same vendor, that was the trick. That's where above all doesn't really work because, of course, you need that interoperability. That's when you can use that MLAG over all of those. All right, don't worry. You have another option. You have another chance. This is a giveaway question number 2. It's my own typo, but it is the second one. And this is from Nathan's Einstein genius-like deck. What is a deployment method for achieving resiliency that will make use of an underlay overlay technology? Choose the best answer. Multiple choice again. Ready? Wait for it. Wait for it. And which is it? Wow, we got some fast typers out there. We got some fast typers. I'm going to be looking at the sub-second timestamps on these answers because yes, all you out there are going after it. This is actually perfectly campus fabric. So for those of you who answered correctly, you're a genius. You're awesome. Thank you for playing. I'll be checking the timestamps and we'll reach out to who will be the winners of those MS-130. And we are super thankful that you've joined us with our Mastering Always On Resilience, High Availability, and Upgrades with Cisco. Thank you so much for joining. We'll be reaching out soon, and you better reach out to your Cisco and WWT account reps. Thank you.